The year is 2025. A year that was once a distant future is now our present reality, and with it comes a sobering truth. Scientists at the Met Office have issued a stark warning, a warning that echoes through the halls of laboratories and conference rooms around the world. Earth is veering dangerously off course from the critical goal of limiting global warming to 1.5 degrees Celsius. This deviation is not just a number, it represents a significant shift in our planet's climate stability. This target, set by the landmark Paris Agreement in 2015, represents a threshold beyond which the planet faces catastrophic and irreversible climate change. The agreement was a beacon of hope, a collective promise to safeguard our future. The consequences of exceeding this limit are dire, ranging from more frequent and intense heat waves, droughts, and floods. These events are not just statistics, they are real, tangible impacts that affect millions of lives. To rising sea levels that threaten coastal communities worldwide, entire neighborhoods, cities, and even countries could be submerged, displacing countless people and disrupting lives. The Met Office's warning, based on the latest data and climate models, paints a sobering picture of the planet's health. These models are not mere projections, they are grounded in rigorous scientific research and evidence. Despite international pledges and efforts to curb greenhouse gas emissions, the world is not on track to meet the 1.5 degrees Celsius goal. The gap between promises and actions is widening, and the clock is ticking. This failure to act decisively has pushed the Earth closer to a climate precipice, jeopardizing the well-being of current and future generations. The impacts are not just environmental but also social and economic, affecting the most vulnerable among us. The situation demands urgent and coordinated action on a global scale to avert the worst consequences of climate change. It requires a unified effort from governments, businesses, and individuals alike. The urgency of the situation cannot be overstated. Every moment of inaction brings us closer to a point of no return. Every fraction of a degree of warming matters. Each increment represents a step towards more severe and unpredictable climate impacts. Each increment of temperature rise increases the likelihood and severity of extreme weather events, disrupts ecosystems, and threatens human health and livelihoods. The ripple effects are far-reaching, affecting food security, water resources, and biodiversity. The Met Office's warning serves as a wake-up call to governments, businesses, and individuals worldwide, a call to action that cannot be ignored. It is a clarion call to rethink our priorities and take bold steps towards sustainability, a call to action to accelerate efforts to reduce emissions, transition to clean energy sources, and build a more sustainable and resilient future. The solutions are within our reach, but they require commitment, innovation, and a collective will to change. The future we envision is one where clean energy powers our homes and industries, where green spaces thrive, and where communities are resilient to the impacts of climate change. It is a future where we live in harmony with nature, ensuring a healthy planet for generations to come. Achieving this future requires collaboration and solidarity. It means breaking down barriers and working together across borders and sectors. It means listening to science, embracing innovation, and making tough but necessary choices. The path ahead is challenging, but it is also filled with hope and possibility. By acting now, we can steer our planet towards a brighter, more sustainable future. The time to act is now, and together, we can make a difference. Data from the Mauna Observatory in Hawaii, a sentinel of atmospheric change, tells a grim story. This remote outpost, situated high on the slopes of the Mauna Loa volcano, has been a critical site for monitoring the Earth's atmosphere for decades. Its unique location, far from major sources of pollution and at a high altitude, makes it an ideal spot for collecting pristine air samples. The observatory, perched atop a volcano, has been tracking atmospheric carbon dioxide levels since the late 1950s. This long-term data collection has provided invaluable insights into the changing composition of our atmosphere. The instruments here are meticulously maintained and calibrated to ensure the highest accuracy in their readings. Its measurements provide a stark visual representation of humanity's impact on the planet. The data collected here is not just numbers on a chart. It is a clear indicator of the profound changes occurring in our environment. Scientists analyze this data to understand the trends and predict future changes in our climate. The iconic Keeling curve, named after the observatory's founder, Charles David Keeling, shows an unrelenting upward trend in CO2 concentrations. This graph has become a symbol of the ongoing increase in greenhouse gases due to human activities. Keeling's pioneering work laid the foundation for our current understanding of the carbon cycle and its impact on global warming. In 2024, the Mauna Observatory recorded the fastest annual rise in carbon dioxide levels in recorded history. This unprecedented increase is a stark reminder of the urgency with which we must address this issue. The scientists at Mauna Loa work tirelessly to ensure that their data is accurate and up to date, providing a crucial resource for policymakers and researchers worldwide. This alarming surge pushed atmospheric CO2 concentrations to over 420 parts per million, a level not seen on Earth for millions of years. Such high levels of CO2 are associated with significant changes in climate and ecosystems. The historical comparison charts show that we are entering uncharted territory, with potential consequences that are difficult to predict. The last time CO2 levels were this high, global temperatures were significantly warmer and sea levels were much higher than they are today. This historical context underscores the potential for dramatic changes in our climate if current trends continue. Warmer temperatures and higher sea levels could lead to widespread disruptions in natural and human systems. This rapid increase in atmospheric CO2 is a direct result of human activities, primarily the burning of fossil fuels for energy. Industrial processes, transportation, and deforestation all contribute to the rising levels of carbon dioxide. The smokestacks and power plants depicted here are just a few examples of the many sources of CO2 emissions. The implications of this carbon surge are profound. Scientists warn that continued increases in CO2 levels could lead to more severe and frequent climate-related disasters. The graphics and discussions among scientists highlight the interconnectedness of various climate impacts, from extreme weather events to shifts in ecosystems. Carbon dioxide is a potent greenhouse gas, trapping heat in the atmosphere and driving global warming. The greenhouse effect diagram illustrates how CO2 molecules absorb and re-radiate heat, leading to a warming of the Earth's surface. This process is a fundamental driver of the changes we are observing in our climate. The more CO2 we pump into the atmosphere, the warmer the planet gets. This relationship between CO2 emissions and global temperatures is well documented and supported by extensive scientific research. The charts showing temperature rise provide a visual representation of this critical connection. This warming effect has cascading consequences for the entire Earth system, from melting glaciers and rising sea levels to more frequent and intense heat waves, droughts, and storms. The time-lapse footage of melting glaciers and the images of flooded coastal areas serve as stark reminders of the tangible impacts of climate change. Extreme weather events, such as hurricanes and wildfires, are becoming more common and more destructive. Reducing CO2 emissions is therefore essential to mitigating the worst impacts of climate change. Transitioning to renewable energy sources, such as wind and solar power, can significantly reduce our carbon footprint. Reforestation efforts also play a crucial role in absorbing CO2 from the atmosphere. By taking these actions, we can work towards a more sustainable and resilient future for our planet. Adding to the complexity of the climate crisis is the emergence of a potent El Niño event in the tropical Pacific Ocean. This phenomenon, which has been studied extensively by climate scientists, is known for its significant impact on global weather patterns and climate systems. El Niño is a climate pattern characterized by the unusual warming of surface waters in the central and eastern equatorial Pacific. This warming is not just a minor fluctuation. It represents a substantial shift in oceanic and atmospheric conditions that can have far-reaching consequences. This warming disrupts weather patterns worldwide, typically leading to increased rainfall in some regions and droughts in others. For instance, countries in the Western Pacific may experience severe droughts, while those in the Eastern Pacific could face heavy rainfall and flooding. El Niño events occur irregularly, roughly every 2 to 7 years, and can last for several months to a year or more. Historical data shows that these events have varied in intensity, with some being relatively mild and others causing significant disruptions. The 2024 to 2025 El Niño event is shaping up to be a particularly strong one, with the potential to exacerbate the impacts of climate change. Scientists are closely monitoring ocean temperatures and atmospheric conditions to predict the possible outcomes of this event. El Niño events typically lead to a temporary spike in global temperatures, as the warmer ocean waters release more heat into the atmosphere. This release of heat can contribute to a rise in global average temperatures, which can have a cascading effect on weather patterns and climate systems. This warming effect can amplify existing heat waves, making them longer, hotter, and more dangerous. Urban areas in particular can become heat islands, where temperatures soar to life-threatening levels, affecting vulnerable populations the most. El Niño can also shift precipitation patterns, leading to more intense rainfall and flooding in some areas and prolonged droughts in others. This shift can disrupt agriculture, water supply, and overall ecosystem health, creating challenges for communities dependent on stable weather conditions. The combination of a strong El Niño event and ongoing climate change is a recipe for climate extremes. These extremes can manifest as hurricanes, typhoons, and other severe weather events that can cause widespread damage and loss of life. The record-breaking temperatures experienced in 2024, for example, were likely influenced by the developing El Niño in the Pacific. These high temperatures set new records and highlighted the urgent need for climate action. As El Niño continues to strengthen, it is likely to further amplify the impacts of climate change, leading to more extreme weather events and putting additional stress on ecosystems and human societies already struggling to cope with a changing climate. The interconnectedness of our global climate system means that the effects of El Niño are felt far and wide, underscoring the importance of